Reading Data 2. In this demonstration, we will look at different examples of reading special data. Sometimes the data you are reading in is formatted in special ways. The most common example are dates. Another example are commas embedded within a number. To read this type of data, you will have to tell SAS about this formatting. Also, character variables longer than 8 characters require special attention. We can read this type of data using special informats. So in this first example, we are creating a data set called tax info, and we are using a colon modifier to add an informat in list directed input. So we're placing a colon after the variable name followed by the informat. So here we are inputting first of all Social Security number, SSN, with a colon, and the informat has a $11 dot. So this means that we are inputting a character variable that is 11 digits long. Then we are inputting a variable called tax date. We have a colon, and the informat that goes with tax date is of the form MMDDYY 10 dot. The length of the date is actually 10 digits. And then we are inputting a variable income, which has a comma embedded in it. So we're using the informat comma 6 dot. Notice here that when I do a print of this data set, I'm also including a format statement for tax date and income. So to input these special variables tax date and income, we use an informat. And to print them out, we use a format statement. And we're going to be talking a lot more about format statements a little later in the class. For Social Security number, we don't need a special format. All we wanted to do was to tell SAS that the length of the Social Security number is 11 digits and that it's a character. So let's run this data and see what the output looks like. So here we are reading and displaying variables with the special formats. And so notice that our tax date and our income appear as we wanted it to appear. And Social Security number is its full length of 11 characters long. In this next example, we are going to, instead of using colon modifiers, we are going to use the Infirmat Statement. So this is an alternative way to associate variables with an informat. So the Infirmat statement precedes the input statement. For column style input that does not use pointers, you need to use an Infirmat statement. So here we have the exact same code, the exact same data that we're reading in, but notice here that our input statement just lists the variables that we're reading in, and our Infirmat statement tells SAS how these data appear. So again, the Infirmat statement says that Social Security number is a length of 11 and it's a character variable. Tax date is in the format MMDDYY 10 dot, and income is a comma 6 dot format. Again, I want to remind you that anytime you're using an informat or format, the name itself ends in a period. So if we run this code with the Infirmat statement, you'll see that again we have the exact same output as we did in the first set of code. Another way that we can make sure that SAS reads in the character string with enough digits or enough of a width is by using a length statement. The length statement allows character variables to be longer than the default width of 8 characters. The length statement comes before the input statement, so the length of the variable is set up before the variable is read. So here we have a length statement for Social Security number. So we're just saying length SSN dollar because it's a character variable and the width of 11. And so in our input statement, we no longer have a colon modifier for Social Security number, but we still have the modifiers for tax date and income. So if we run this code, again, we are going to get the same print out as we did previously. So each time we run this code, we've gotten the exact same display of data. SAS allows a lot of flexibility in the way we input our raw data. So here, in this next example, we're showing that we can actually mix input styles. So the following example shows how we can mix and match the three major input styles: list input, column input, and formatted input. So here is another way of writing the input statement for Social Security number that doesn't require a length statement. So here what we're doing is we're now using column format, and we're saying that SSN is in columns 1 to 11. So automatically SAS is going to create a length for SSN of 11 digits wide. And then we're using colon format to tell SAS that tax date is in the form of MMDDYY10 dot, and then we're using a pointer and an Infirmat to show that income is in column 24 and it has the Infirmat comma 6 dot attached to it. Once again, if we run this code, we will get the exact same output as we did with all of the previous codes that I've run. Now we're going to switch and look at some other examples of special types of data and how SAS can read it in. So here is a data. This is a list of variables, quality of life variables, where each quality of life variable is only 1 digit wide. And so we're going to read this data using an Infirmat list. Many variables can be read in with little coding if you use a vector type names for variables, and each variable has the same Infirmat. So this example reads in 35 variables with the names QL1, QL2, all the way to QL35, starting in position 1. And each of these variables is 1 digit long, and it's a number. So each of these variables are responses to a quality of life question, and the responses could range anywhere from 1 to 6. So if we highlight this data and run it, we are going to see 35 variables and 3 observations. And each of these 35 variables has a numeric response ranging from 1 to 6. Here's another type of data that we're going to look at. So sometimes it is convenient to input more than one observation per line. To do this, you need to use the trailing @ signs to hold the record. The data set created here has 10 observations, but it is input in just 2 lines. So here we're only inputting 2 variables, student ID, which is a character, and grade, which is also a character. But this double @ sign at the end of the input statement tells SAS to repeatedly input just those 2 variables until it gets to the end of a line of data, and then go on to the next line. So although we're only showing 2 lines of data under our data line statement, we're actually creating 10 observations because of using this trailing double @ signs to hold the record. And we're creating a data set. This is again a temporary data set called final grade. So let's run this and take a look at what our printout looks like. And here we are. We're reading multiple observations per line. So we now have 10 observations. Each observation consists of the student ID and the grade. It's also possible that you can have data that appear on 2 lines per observation. So here we have a more complicated data set. This is a data set called AFIFI, and we will be looking at this data set in more detail in later classes. But data was collected for 113 patients at the Los Angeles County Hospital Shock Unit. For each patient, data was taken on admission and either shortly before death or before discharge. Variables on the first line refer to data at the initial examination, and variables on the second line refer to variables at the final examination. So here is a listing of the first 4 lines of the raw data. So it's shown below, and these 4 lines make up just 2 observations. The first observation is patient ID 340. The second observation is patient ID 412. So we're going to be reading this data in as column style input, and we're going to be reading it in from 2 lines per observation. So in our input statement, we start with number 1, indicating our first line of data. And notice that we're actually not even reading in all of the variables. We're reading all the way through column 24, and then we're skipping and reading hemoglobin at baseline from column 69 to 72. So this again is one of the advantages of column style input. You don't have to input all of the variables. You could selectively input variables because you're using column style input. The other thing I want to point out is that there is a 1 dot that goes along with hemoglobin at baseline for column 69 to 72. And that's because we want to attach an Infirmat to this variable hemoglobin, and we want SAS to put a decimal point in the variable hemoglobin so that it will appear as 2 digits and 1 digit to the right of the decimal point. So let's run this code and see what our output looks like. Notice here that hemoglobin is shown as a number that's 4 digits, and there's just 1 digit to the right of the decimal point. So it's shown in the correct measurement levels. And we see here that there were 10 observations read from our data set. And so we also have age and gender, which is coded, and some of the other variables that we read in. Here is an alternative way to read in data from 2 lines. So in the example that I just showed you, when we had the input statement, we had a number 1 and a number 2 to tell SAS to read the observation from 2 lines. The alternative way is to use a slash. So we start with our input statement and then the variables we want from the first line of data for that observation. And then the slash tells SAS to continue reading data for that observation from the second line of data. So again, this is just an alternative way of reading in data that's on 2 lines per observation. So again, if we highlight this code, we are again reading column data that is on 2 lines per observation. And as before, we had that Infirmat for hemoglobin so that the hemoglobin appears in its correct units. And here again you see this were the Infirmat that was used for hemoglobin, the .1. Let's say we want to read part of a raw data file. And this comes up on the base SAS certification exam. So occasionally you want to read a small portion of a large data file. To do this, you use an input statement with a single at the end. This tells SAS to hold that line while you examine the observation with an if statement. This kind of data we're not going to typically work with in our class, but I wanted to show you some examples of it because I know it comes up on the base SAS certification exam. So here we're creating a temporary data set called Condo Ranch. And notice, just for a change, I wrote this data as data work.condoranch. Again, I don't need that prefix work, but I decided to include it because I haven't done that before. Then I have our in-file statement, data lines, and notice I'm using the DSD option to tell SAS that the data is comma delimited. And the reason I'm using the DSD option is I also want to have the commas that are between the quotes to be printed out. And so, as I mentioned to you earlier with the DSD option, if you have quotes and a comma is within the quotes, then it's not going to be viewed as a delimiter. So I'm starting my statement if style equals condo or style equals ranch. That means that only the condo and ranch homes are going to be read in. Then input the square feet, the bedrooms, the bath, the street, and the price. And in the price, we're going to have a $10 dot format attached. The at statement says, first of all, input style. So the variable that's going to be input is the type of house. And then with the if statement, we're going to check, is the house a condo or is it a ranch? If it's one or the other, then that's going to be input into our data set. If it's any other house type, it will not show up in our data set. So let's run this code and see what happens. Notice here that only 3 observations are printed out. And the 3 observations were the 3 homes that were either a ranch or a condo. And it lists the square feet, the bedrooms, the bath, the street, and the price. Now let's say we're going to do something slightly different. Again, we're interested in reading in part of a raw data file, except occasionally we want to read just selected variables for certain records. To do this, you use an input statement with an at the end, and this tells SAS to hold the line while you examine the observation with an if statement. But here, it's going to be slightly different. Here, additional variables will be read in if and only if the style is condo or ranch. But in this example, all the observations will be read into the data set. So let's look at how this is slightly different. In this code, we're creating a data set called condo ranch. We're inputting style, and we have our single at the end. So SAS is holding the observation while it checks if style equals condo or style equals ranch, then input these other variables. So in this bit of code, we actually have 2 input statements. Again, we have the if statement, condo, or if style equals condo or style equals ranch, followed by the then we would input these other variables. So in this example, we're going to have all of the observations read in, but only the observations where the style of house is a condo or a ranch do we have these additional variables also included. So notice here we have all 7 observations, but only the ranch and the condo show the square footage, the number of bedrooms, number of baths, street location, and price. The other variables, they didn't read in those additional, the split level, 2 stories, they didn't read in those additional variables. And so those variables were just left missing for the homes that were not condos or ranch. So again, I want you to notice the difference in these 2 programs that I've shown you. In the first program, we had an if statement with no then. It was just if style equals condo or style equals ranch. Those were the only homes that were read into the data set. And so we had a data set that was just 3 observations. In the last example, we have if style equals condo or style equals ranch, then input. And so we had 2 input statements, but all observations were read into the data set. This finishes SAS demonstration reading in data 2.